is represented as 3 bits. Can you please, whoever, left his mic on, to mute it, please? The address is represented as 3 bits ranging from 000 to 1111. Yeah? So this is the example that I was explaining. Is this clear? Right. Now, we have 2 operations that we can do with the memory. We have read operation and we have the write operation. The read operation is the operation where the binary word stored in a specific address is read and transferred to another device. Or it could be transferred to another memory location in the same memory. So we go to one memory location, we read the content of this location. The content is the word. So we read it. The write operation, the read operation, we call it as well the fetch operation. If you read, those who study, computer architecture and even in embedded system, we use the word fetch. The CPU fetches the data from the memory, or fetches the instruction from the memory. As you know, the code that you write, we mentioned this the first sessions. The code that you write, when you compile it, it will be translated into all binary, and then it will go to a memory program. We call it a program memory. And this is the memory that the CPU uses to get the instruction. So when you start the code, it goes to the first memory location, it gets the instruction, and then it's decoded. Of course, this is done by the brain of the brain, as I said it, the control unit. So the control unit fetches the information, fetches the code from the memory. So it needs to perform a read operation continuously. When it finishes with one instruction, it goes to the next one, so it fetches the next instruction, so it's another read operation, and so on, until it finishes with the code. So this is we call it read or fetch. We have the write operation or store. We call it as well store. The operation is the operation where a new word is placed into a specific memory location. So we always need to specify which memory location we need to read from or we need to write to. Also called stored, as I said, operation. The new data will be replaced, overwrite the previous stored data. Of course, memory has always data in it. Once you write, you will overwrite whatever is there in the memory location that's your interest. So you overwrite the data with the new data that you want to write. So for example, if I have a variable in my code, the variable is changing, the CPU will continuously go to the memory and write the new value of the variable. As I told you, when you declare a variable, there will be memory location reserved for this variable, and then it will be updated while the code is in execution. How do we update it? Of course, the CPU perform write operation. Right. We are still with, this is general memory operation. So every memory system, of course, the memory is a chip, as we said. So it has inputs and outputs. So it is a chip that has inputs and it has outputs. So what are the inputs and the outputs that we have in this memory? So what do we need as input and what do we need as an output? So so every memory system requires input outputs to provide the following functions. So in order to read and write, we need a data bus, right? The first thing that we need is the address. We need an address. So we have an address, what we call an address bus, sorry. We have an address bus. So one of the things that we have in memory is the address bus. This is M. It will depend on the size of the memory, right? So the example that we did before, if I have 8 memory locations, then N is equal 3. If I have 16, then N is equal 4, and so on. If I have 32, then n is equal 5. So this is the address, we call it the address bus. So this is the first thing that we need. We need as well to select either it's a read or write operation. So we need one pin, and usually it's called RW bar, to specify it is what do we want. Is it a read or write operation? So if I want a read operation, I will put 1 here. If I want a write operation, I'll put 0. So 1, this means what will follow is a read operation. 0, what will follow is a write operation. Right? So we select either a read or write operation. We need to supply input data to be stored during a write operation. If I want to write, then I need to specify the data that I want to write, right? So I need a data in, and this is again is M. What is M? M is the size of the memory word, right? So if I say 816 by 8 memory, so this means the address N for the address is equal 4, and M is equal 8, because the size of the word is 8 bits here. So this is 8 bits. I need to provide 8 bits, right? If I want to write data, I need to provide 8 bits. So data in, the size is M. I'm putting general case here, but of course the M is equal to the number of bits, or the size of the word size. We need as well to hold the output data from memory during a read. When we read, we should get an output, right? The data that we want to read. So we have another data bus, which we call data out. And this is M as well. And of course, we have, like most of the kits, we have the chip enable or the chip select or memory enable. This is to enable or disable the memory. So this one is CS or chip enable or ME. They are the same. So if it's 0, then the memory is disabled, which means you will not get data from it. It will not, even if you want to access it, there will be no data provided, no data out from it. And you cannot write to it as well. You cannot write, you cannot read. Right. And this pin is very important when we work in a system where the memory is shared by multiple devices. You cannot, the multiple devices cannot access the memory at the same time. So it needs one by one. So it needs to be disabled for one and enabled for only one chip, or for only one device to access the memory. Is this clear? So this is very important, this chip enable and chip select. So those are the pins that we have in the memory. Of course, depending on the type of the memory, ROM and RAM, we may have all of them, you may have only some of them. We will talk about this. But this is in general, those are the pins that we need in a memory. Another point is, you see this data in and data out. So memories, they have separate buses like this. One is input, one is output. But you can find as well some memories, they have bidirectional bus for data. And this is M. So input, it can be used as an input, can be used as an output. So again, it depends on the memory. When you buy the memory, you go to the data sheet of it, and then it will give you all the details. Of course, you don't find both of them like this, bidirectional data bus and data in and data out. So either the first one, the one in green, or the one in red. So one of those. This one or this one. Is this clear? Right. So those are the things that we need in a memory. So this is what I was explaining in this slide. So if we take an example, another example here, if you can do it quickly, 32 by 4. 32 by 4. This means the size of each memory location is 4 bits, or the word size is 4 bits, and we have 32 words. So what is the address bus? How many bits? So the address bus is 5 bits for 5 lines, right? 2 power 5 is equal to 32. And this is what we have here. Address input, 5. This is the address. And then, of course, we have read-write command. We have the chip enable. We call it here memory enable. And the memory that I put here, it has data input bus and data output bus. So we have 4 bits, because the size of each memory location is 4 bits. So each one is 4 bits. Is this clear? Right. I think I talked about all this stuff here. Read-write. If read-write is 1, then it's read operation.